Good morning, my outstanding friends. They're talking about Bennu right now, building blocks of life discovered on this distant asteroid, Bennu. This is Nova from PBS, Public Broadcasting. How did life originate on Earth? They're going to show what they brought back from Bennu, and I'll show you how life originated, not necessarily on Earth, but how life and where it is, and how possibly it originated. Nobody knows how it originated, I can guarantee you that, but I can show you where it does exist. Okay, my friends, they went out to Bennu and they picked up a sample. They came back and they say, how can we analyze, how can we better understand what this is all about? Well, this is what they came back with. These two white layers are phosphates. They're made from phospholipid layers. These blocky little things are what's called sarcomeres. That's these blocky little things right here. Those are in between the phosphate layers, or phosphate, sarcomeres. On top of that is another phosphate, and then more sarcomeres. Again, in addition to that, you can see these little bundle-looking things that they came back with. This, my friends, is biology, and I know exactly what it is, and you will too right now. It is from a heart. These are heart sarcomeres. Those are the little blocks. These are the phospholipid layers, phosphorus, phosphates. Phosphate surprise, they never knew it was there. This is a heart attack victim here on Earth, and what they came back with was heart sarcomeres. Here they are right there. Same stuff, same identical stuff, same stuff between, because they're membranes. They said, "Ooh, phosphate surprise, we never expected that." Well, they didn't expect it was a heart. And here it is right here, it's a heart. These are the valves of the heart. There's the big one, I guess it's probably the aorta, and these are the other two valves. And they're looking at these boulders and say, how did all these boulders get on here? This is a pretty good sized thing. This is like a third of a mile or more across. And it is a heart. And this is a heart too, which is Psyche, and this is gigantic. I think it's 140 miles. Look at this. That's a tube coming out of the heart, and so is that. These colors are the colors of blood. All the Mudfossil people know that the blood is the red, the black, and the yellow. The red and the black are separated by yellow. The red and the black will not merge with each other. There'll be yellow in between, or there'll be nothing in between. There'll just be a band. It's called iron banding. This is iron, and it's because of the polarity, well, the ionization actually, this FeO2 and O3 blood. It's a heart. That's a heart. This is what hearts look like when they lose their plumbing. And they lose their plumbing because there is iron banding at the plumbing, and I'll show you that in a second. These are the valves. The same as on Psyche, the same as on Bennu, and they break right here. And why do they break right there? Well, it's because of iron banding. You see the red and you see the blue? That goes right around the heart, and they push each other apart. Stip, and it pops the top right off. Autopsy guys, I talked to him and I said, have you noticed that the heart just falls apart? And he says, yeah, I always wondered about that. They take it apart and it just falls apart, because of the pushing apart of the red and the blue at that particular glued layer. Pops right off. And that happens regularly. That's not just something one shot here or there. That red and the blue just makes it snap right open. What else? This is what sarcomeres are. These are heart sarcomeres. This is exactly what you got. There's no question about it. It has all the amino acids. It has all of the chemistry. It has the uracil, which works with the DNA. It's got 16,000 molecules that we have in our blood and chemistry. It's got the anatomy that's just undeniable. It's a heart. It looks like a heart. Not only that, this is just one of the things that's in space. They're all the same. It's all biology. Even this right here, you see, this is Mars. Elon Musk wants to go to Mars. Guess what he's going to find? Muscle sarcomeres. They say this happened over continually millions of years. No. This was a gigantic creature, died here, just like the things with a 140-mile wide heart. That is muscle. And not only that, there's the Mars crab, the Mars blueberries. All biology. And this is Mars. Don't tell me it's not Mars. There is no water erosion here, just dust. You cannot have that happen on Earth. There will always be some form of little rivulets or something in dust. This is a dry environment. This is Mars. I study this stuff very, very carefully. So don't come up with these nonsense things. Oh, they can't go to Mars, da 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 da. Forget that. Now, that's Mars. And this is Mars too, the Mars crab. Right there. You say, well, what is that? NASA says, see, this is a NASA picture. This is 2015 or 2014. When Curiosity first landed, they say, oh, what the hell is that? Oh, don't look at that. Because people were saying it's a crab. It's not a crab, it's an artery. And that artery has all of these little blood vessels sticking out to service the muscle here. And that top tube is the vein coming back to be reinitialized. And this is more sarcomeres, because it's muscle. And that's where the crab is right there. And it's got all those little things going on. I have one of those here in my shop. A little small, huh? Here it is right here. This is where the crab would be, but the legs have fallen off at this one. But that would put all kind of blood flushing down to that muscle. That's muscle. That right there is tendon. And that's the abrupt transition. And then back here, I don't show it on this picture, but back here, this is the same piece. Back here is a bone. You see the bone? And then that comes up to the tendon, which is here, and it's pinned, literally pinned to the tendon, and then the tendon gives way to the muscle, and these are the muscle fibers and the bundles, they just break off. You see, this gives a better shot of the colors. Red, anytime you see red, you got blood. This is bloody muscle, and it gets weak as it comes into the sarcomeres. The original transition between the tendon, you see, is there's no color at all. This is just solid rubber band. And then it abruptly transitions into muscle. However, the muscle continues on with a lot of mineralization, so that it's still got some really tough stuff. And then it gets to the muscle sarcomeres, and they're just like this. But here it's still got that connective tissue right about here. There's several abrupt transitions. There's, of course, an abrupt transition from the glue. There's the abrupt transition from the tendon to the muscle. There's other abrupt transitions, you see right there, where it starts to give way of its fibers. And then about out here, you don't have all that heavy-duty connective tissue anymore. So now that I've shown you that these things that are on Mars and Bennu and all that stuff is biology, you say, well, that's just an anomaly. I said, no, it's just not, it is the norm. These metal meteorites that come through space, they call them iron meteorites. They're loaded with all kinds of metals. Not only that, they're loaded with blood. That's an iron meteorite, and there, right there, is the red blood, and there's the vein blood. The red blood is the artery blood, and that's the vein blood. You see the black? Everybody knows the Mudfossil people. There's a little round dot. What's it doing there? Well, it's because it's blood. And that right there is the vein, the artery, the red. What's it doing in the middle of a heart? In the middle of a iron meteorite. And all these little crystals and so forth, those are the different types of metals. They flocculate together. And, as they crystallize. This was big enough that it completely melted coming through space. I have some meteorites here that are small enough that they didn't melt completely. And I can tell you what that is right there. That's right there is a lung. There's no question about it. When I put it in a microscope, it's absolutely certainty. And they come much bigger than this. And when they're bigger, they melt more. But it's when they're hearts, lungs, and livers. They come through and they turn into iron meteorites. Then you have other ones that are other body parts, and this is a body part too. This is a stony meteorite. All right, it came through and it didn't have enough blood in it to turn into iron, or metal, basically. Iron is primarily mostly what your blood is made out of, iron, FeO2, 3, so forth, which absorbs the oxygen. but there's every other metal is in there. I sent them a study of the metals that they would find in the heart before they even came back with it. And there was a study of 26 metals in all 3 states of blood, the plasma, the whole blood, and whatever. And I sent them all the chemistry. I said, this is what you're going to find. And there's 26 different metals in there. There's no question about it. And that was before they came back. And when they did come back, and when they finally opened up the capsule, and I saw the sarcomeres, I freaked out because I knew it was a heart. But anyway, this is a fingertip from a giant creature, and there's a terrestrial one right there, exactly identical, even with the hook and everything. See the hook? You see the hook? You see the veins, vein. That right there is a vein, and that's a vein. On the other side is the arteries. The arteries blow out. And this coming through space was still wet in here. And it came through, got real hot, blew that side right off. And I drilled a big hole in there to get way deep inside to get blood, and nobody will do the testing. I did the same thing with this. I drill into them. I don't take it off the surface. Oh, you contaminated this and that. No, absolutely not. And the first ones I had done came out to be human, which were from here on Earth, and they're giants. 2 of them were giants, and 1 of them was normal size. And they came out to be human. And after that, the guy got assaulted, and I was assaulted, and nobody would talk after that, and they still won't do any tests. This is exactly the same. Even that. You see that wrinkly little spot there? That's a tendon. The same thing here. It's the same spot. Here's the same where the blood is. And here's where it blew out there. It's identical. There is no difference whatsoever. This guy's a little smaller, and it was terrestrial. That came through space, and he was a little bit bigger of a guy. There is just nothing but biology here on Earth. Zero except biology. Here's another one that came through space. This, I'm not sure what it is, but it's been the surface has been boiled off basically down to where you have those grippy things down here like that, like this thing here. And that's the thickness of the skin that was on this thing. This was a big creature. You see the thickness of that skin? And this right here is just like blood, because when it came through, it was still wet. Watch this. You see this right here? This is a tendon strap. It comes down like this, and that has a ball underneath. And originally that was a flat piece right across the top. When it came through space, it was wet with red blood, and popped this piece right off. You say, oh, Roger, how could you possibly know that? Well, because I put a little more water on here, and it turns right back into blood. You see that? It turns right back into blood. Blood rehydrates almost instantly. And red blood just explodes because it's wet. Blood stays wet. The red part stays wet forever. The black does not stay wet. The black turns hard and crispy. Here's the artery, and there's the vein. And other than that, it came through space and just exploded. And it's pretty much magnetic, but it doesn't have enough blood in here to turn like the iron meteorites, because they're lungs and hearts and livers. All right, we got a lot to go over, but what I want to focus in on is asteroid Bennu, that they picked up a sample, brought it back to Earth. We're going to focus in on that, and then we're going to take a look at the moon. All right, I'm just going to give you another little taste of what's out there. This is Comet 67P. It's a hip joint. It's a hip joint. And it is spewing out gases from its veins, from its artery. That's a 500-foot artery. I go into this extreme detail. It's going to take a while to do this. But this is the artery. These are the blood vessels. It's cooking in space because it's being hit exactly direct. And all the astronauts say space smells like steak. And here it is. This is what a hip joint looks like. And it broke off somewhere up here. That's it. And it's spewing out those gases as it cooks in space when it gets close enough to the sun. This goes back 10 years ago. I studied this stuff for a very long time, and I tried to get a hold of NASA and everything about everything, the biology that's on Mars, and I'm going to show you about the moons and everything else. There is nothing but biology. Zero. Every single thing there is biological. I can't find anything that's not biological. Nothing. Oumuamua, 67P, all of the moons and everything. Just stay tuned. You're going to see. It's a shocker du jour, but this is what it is. Okay, my outstanding friends, these are the amino acids they found on Comet or asteroid Bennu. These are exotic little chemicals. They don't come off by themselves. This is a product of life, and Bennu is a product of life as well. 7 years ago, they went up to Bennu and they collected a sample. It landed here on Earth last year, and it's biology. See this? How this all relates back to the origin of life. There is nothing but life. Now that they found the biology on Bennu, they say these carbon-rich asteroids delivered these particles not only to Earth, but not only to the early Earth, but to Venus and to Mars as well. Well, I'm going to tell you what, Bennu didn't deliver them anywhere. Everything is biology to start with. Okay, this is the Blue Ghost mission to the moon. They landed with 10 scientific instruments designed to analyze
the moon's surface and subsurface. One of the key experiments, LISTER, the Lunar Instrumentation for Subsurface Thermal Exploration with Rapidity, kind of sounds made up, is drilling into the regolith to...
All right, first of all, what is regolith? Regolith means coating, crust, surface. So they're expecting a solid, or at least more solid, or at least another layer under this regolith. So let's go back a hair here.
Is drilling into the regolith to measure how heat moves through the lunar surface. This data is crucial for understanding the moon's internal structure and terrain stability.
Okay, they want to know the internal structure and about the terrain. Now, I either have shown you or will show you an area on the moon that suggests to me that we can make a determination of what those materials will be.
Practical knowledge for building permanent lunar bases. Another major instrument, LEXI, the Lunar Environmental Heliospheric X-ray Imager, is studying something even bigger than the moon itself. How Earth...
Well, then they're going to get into the magnetic fields. Well, watch.
Earth's magnetosphere interacts with solar wind, mapping the invisible force field that protects our planet from high-energy particles and helps us prepare for deep space exploration.
Well, I can show you pictures that are going to be hard to dismiss, that show the fields in space and then show what the moon structure is in layers. Now, this was taken from right here on Earth, from New Zealand, by Dylan Carpenter, who I can't get through to him anymore, so I don't think he wants to be involved. But he did send me a bunch of these pictures he took with his new cell phone, several years ago. And I was totally blown away. And then I tried to recontact with him, and it just never worked out. These are all dipoles, and look at that. Look what the hell is going on there. Look at that little white dot and then a big, yikes. And then you got energy on top of the moon here. Now, either that is on top of the moon or it's between us and the moon. Anytime you see something bright, it means there's energy there. And look at this, and look at this, and look at that. It looks like a pyramid, and that looks like Atlantis or something. This is crazy stuff. And these are all fields that surround all spinning planets. The moon doesn't have a field. This is not the moon's field. This is the field that is in the atmosphere out there. And there is atmosphere. This is not a vacuum. Absolutely not. It's saturated with particles, first of all, and dust, and all kinds of everything you can think of. And then everything has its own magnetic field. As it bumps and scrubs through that stuff, it creates these vibrational waves, and they get less and less and less impactful as you get further and further out, so they spread out further. That's like basically a redshift of magnetism, basically. And the other thing you want to take into account is the redshift that they see in with the Webb telescope and all that, thinking things are such a distance away because there's no slowing down or speeding up light. That's just not true at all. And there is no homogeneous space, so you can't say, well, we know it's going to take a factor of 5 or something. No, there's no factors, because this could be 3 times as dense as this, and it's just there's no way they can use that Webb telescope to determine any distances whatsoever. And this, I think, deserves a little examination. And that's just not the only one. Hold on a second. This one here, I think that's the Seven Sisters. You see it? I really don't know. I didn't take these pictures, and I have no access to them. I'm not going to do them. I don't know what kind of phone he had. I don't know what kind of app. But I can tell you what, these are exactly what I expect. And this is a very strange dipole situation. There's the 2 black ones here and all the white ones on that side. Very, very strange. And that's the moon in the middle. And it looks like these are radiating onto the moon or something. You see that in the front there? I don't know what to think about some of these things. I really don't. I'm not trying to show something that and claim that I know everything about it, because I do not. But I do know this. This right here is a shot of the moon. What are you seeing? This is what they call a regolith. That, my friends, this is biological. I'm just going to tell you right up front, this is biological. And right underneath here, they're going to find a phosphomembrane, a phospholipids, phosphates. And then below that, I'm not sure what they will find, but this is a tendinenthesis. It's a tendinenthesis. I don't care what anybody says. And that right there is the artery entry, and that is the vein. And the reason it has a little dot there is because that is a valve. Veins only let things go one direction and not the other. Arteries wide open, no valve. And this is, there was an attached cord pulled right off of there. And that's why you see it, follow this around. You see that? And all these little bumps all over the moon, they always say, oh, there's little craters. Well, I'm sure there's a lot of them, yes. But there's a lot of them that aren't craters, and they're just part of that particular type of a structure. And this is where it pulled off right here. These are all the little dots all over it, just like Mimas and Tetchus. And a lot of the moons have the same thing. They have a cord that snapped right off, just like that. And it left the center. The center usually has a little bit of an extra hardness to it. And then it has a layering all around it, and it just snaps off just like that. And that's a tendinenthesis. In us, you need a microscope to see that. And these are moons, and this is our moon too. All right, and that's where it snapped off. And you have to have blood and vein and artery going into every bit and piece in your whole body, and that's it right there. Now, this, and I understand with the chemistry they're going to find here. I'm pretty well understanding of what this is. Now, there were different types of tendinenthesis, and some of them were like stone under here, really hard stone, like iron almost. And those would be the Moki marbles. But then there was other ones that were like rope-style tendon that came down in big bundles, and I think that might be this. But it might also be the aponeurosis, because I'm seeing this. And the green here, I think that green might actually be where the bacteria was in the fluid-filled highway of this creature, wherever creature it came from. But we're looking at And then there's still a little bit of red blood running down this way, or dusting down that way, or whatever. And this is the membrane that goes right underneath this layer. And membranes are just like that. You have a layer, then a layer, then a layer, and then below this layer, you have this blue layer. But in between this layer and the blue layer is the green. And the green, I believe, is from the fluid-filled highway. You see, you have it everywhere. It's over here. You got to look real close. There's green in that layer. And that is the valve, and that is the artery that serviced this tendon enthesis when it was in some kind of a gigantic, unbelievably gigantic creature. That's the only reason, that's the only thing where I know where tendon balls come from, tendon enthesis. And I do think this is probably an aponeurosis tendon, where the strap came in like this and locked in. Other ones have straight up, like bundles of cords coming out. This is a different style, but it's still the same thing. It still has a tendon that locked in, and then a strap that ran back into some tissue. I mean, look at this. That is body tissue. I can tell you right now, I know exactly what it is. This is going to be the same basic thing you find in clay. It's probably extremely dry, and then the very outer surfaces of this will be ionized quite a bit because it's been hit with radiation from the sun with no protection for I don't know how long. So there'll be ionized surface, and then once you get deep enough, you'll run into like clay mud, just like in the earth. And then below that, you're going to find that membrane, because this is a biological body part. It's what it is. Now, I have another shot of this that shows that is actually, well, let me show you. Okay, my outstanding friends, I'm going to cut right to the chase. Our moon is biological, and these layers, I will explain to you in a moment what they are, and these what they are. And we will be talking about tendon enthesis and moons that have the tendon enthesis torn off of them. I will explain this in extreme detail. We'll be talking about hip joints, which just happen to be floating around in space, broken off in a manner about like this, and that is right here, as a matter of fact. It's Comet 67P. They had a lander up here. It sampled a couple of little bits and pieces called Kenneth and Juliet, and they are biological 100%. It is a tendon enthesis. Not only that, it has a huge artery 500 feet across and a bunch of little blood vessels that service the tissue. What happens is when the sun hits it in exactly the correct alignment, it boils those gases right out of those, because they're nothing more than like cooking in a barbecue, irradiated barbecue. There's no flames because there's not enough oxygen, but the gases are shooting out, and the astronauts say space smells like steak because it's irradiated with it. It's just nothing but biology out there. Now this is 67P from a different angle. This goes back 10 years ago. I was studying this and trying to get a hold of NASA and everything. I said, you got biology here. And that is 500 feet across. And that is the artery shooting out the gases, because the sun is hitting right in there. It's hitting here too, but this doesn't have the blood in it. You see all these little things going out of here? You see them all? One right after the other. All right, boom, 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 all the way around. They're shooting off gases because those are the tiny little blood vessels that surround that hip joint and have to feed blood into the tissue that is up in this area and around in here, because every bit of tissue, every bit has to have blood in it, and it has to be serviced continuously, have more oxygen and nutrients. Now, that is just 67p, and the moon, I said, is nothing more than a tendon enthesis like this. This is just the start. And then we have the sample brought back from Bennu, which is a phosphate layer, muscle sarcomeres, another phosphate layer, more muscle sarcomeres. And this is what they look like. They're muscle from a heart, because Bennu is a heart. This is membrane, that's membrane, phosphates. Membranes are phospholipids. I just showed you what that looks like. Well, guess what this looks like? That's a heart attack victim here on Earth. And that's what the sarcomeres look like. And this is exactly what they brought back. This is a layer of phosphates. Phosphates. That is a layer of tissue, which is the clay layer that they found, and they're little pinchers. They pinch in. They're blocky little buggers. Now, what they brought back was exactly the same thing. Remember, phosphate, phosphate, sarcomere, sarcomere. They could just keep going in a row. There's a whole ton of them. And that's exactly what they found, only they got two layers. They got the phosphate layer, which is a membrane. They got the sarcomeres. They got another membrane. They got some more sarcomeres on top of that. And there it is, really close up, close. Those are little muscle fiber sarcomeres. Now that's on Bennu. Not only that, Bennu looks like this. It's a heart. These are the heart valves. And see this one down here? You got to look close. Take your time. You see this big round one down here? And that little bugger there, they have something there that attaches on that big block. And this here is probably a tube, but they have tubes coming out of them. And these are the valves. There's three big valves right together. And that's what this is a heart. And that's Bennu. They landed here and they just went deep inside. They didn't realize they were going to go so deep. It's basically covered with blood. And then they came back with this chunk of heart. That's heart. And they've been looking at it. They found every single thing the heart has in it. All the sarcomeres, they found the sarcomeres, the membranes, they found amino acids, they found uracil, they found 16,000 molecules that are biological. They found every single thing. And the anatomy's here. Everything's here. Everything. You can't miss it. It's undeniable. So why do they have to study this for 1,000 years here just to, let's figure, what does it mean? We know this is the same thing here. We got gigantic body parts. I mean gigantic. Let me just show you something. Hold on. You see that? This is 40 meters. There's about 4 of these. You got to come up with close to 500 feet. Every one of these little dots, they call these dragon balls. These are the actual, where the blood goes through there. And that's what cooks and sends out that huge, vapor trail that comes out of here. They think that's just dust. No, it's not. That is blowing out from that artery. And it's because the light is going directly down in there, and it's very, very intense as it gets closer and closer to the sun. That's why only when they get close to the sun do they vaporize off like this. And it smells just like steak and metal, because your blood is just saturated with transition metals. It's basically all metals in a fluid, and it carries things around through it. See, this is a spectral analysis of what they found in these molecules. They call it Kenneth and Juliet, which are hydrocarbons, that's human biology. And then they found all the different states of iron that are in the blood. Then they found the silicon, sodium, carbon, all the stuff that we have in us, exactly the same. All the hydrocarbons are identical. And they said, yeah, this is all biology. And they just let it go at that. You see that? I told you, had a 500-foot artery. This is Raleigh, North Carolina. on a very bad day. You know, that's a good size hip joint. You know, every single culture on Earth had the same stories about battles in the heavens, gigantic gods fighting. And now the evidence is overwhelming that it was true. Now look at this. Remember I showed you Bennu. Bennu's a heart. It has these valves, and they break right off here. And it's because of iron banding. It's where the two different red and the blue blood opposes each other. It just snaps right off here. So they end up with this. This is called Psyche. It's just another moon. Another heart that's out there floating around. 140 miles wide. 140 miles. All right? This is, what a heart is, and these are all the things. Now they show it as smelting because they say it's all blood, it's all metals basically, and that's what a heart is because it's all blood. Blood is just saturated with transition metals. They just did a big study on it, and they examined all like 26. They only examined 26 metals, but there was more than that in the blood. They didn't even have iron included in that. They were checking for all of the different metals, which is it's in everybody, uranium and everything. And your body makes it. It's there for a purpose. Your body makes the chemistry it needs using enzymes. A whole lot to think about. This is Mao. All right, have you heard Avi Loeb? He's from Harvard. He testified to Congress about this, or Senate, or whoever they were. He said this could be a spaceship. Well, I tried to get a hold of Avi Loeb about this, and I never got anywhere. But this is grip skin. That's the skin on the tip of a finger. And the skin is eroding. That right there is an apical tuft. This is a strap of the tendon, and right there is all where the little tiny balls lock into the bone. And that is the crease in the bone between the fingertip, right there. And then it runs down again, tendon. Down here you see the black, that's the vein blood. Over there, that's the artery blood. And these are the two tendons that go right over there. Come straight up. This is the bottom side of the finger. That's the bottom side facing us. Now, these are like 2D CAT scans, basically. They take thousands of pictures, and then they take all the highlights and they blend it into one picture that shows this. This is not just ours rendition. This is extremely well done, and it's just like a CAT scan. I had CAT scans done on my stuff, and the CAT scans 2D, which this is, it worked fabulously because you can see every detail. You see the outline of that tendon fiber? That's a very heavy-duty tendon fiber, and these are all little tiny straps. You see those little straps as they come down? See that fiber coming down from the top? Right there is a tendon, is the apical tuft. It's right there. See it? All those little balls would have had straps coming from them, coming all the way down this way, that way, so forth. That's the main center that locks right into that. It's very easy to see. It's identical to this because it is this. It's called an apical tuft. It sits right at the end of the fingertip. And all kinds of tendons anchor into these holes. And you have one big ball at the end, which it's exactly the same. And the skin has eroded off. And that skin is grip skin. It's almost like a rubber glove on a person's hand. Now, this I'm not sure the size. It is good size. And he thought maybe this was an alien spaceship for some reason. And they go, I don't know, they could be living in here. I have no idea. There's plenty of space in here. It depends how big it is, because it had arteries, it had veins, and then you could tunnel any of that stuff out. Very simple. So, but that's Umau, and Avi Loeb, I'd love to speak to him about it, because he says he's done a lot of research on this. He thinks it might be a spaceship. Well, that's possible. All right, there are more than one type of tendon. What I showed you here is the tendon, ball, and strap, which is the rope style tendon. It's this style right here. They're rope, and they come down to a tendon enthesis, and there's just literally tens of thousands of them. This is the same thing. This is okay. What I showed you before was this style, which is the rope style tendon, and it breaks off something like this. Now, let me show you the other style there is, which is the aponeurosis. This tendon is flat, but it has the balls. They lock in there, and they have the straps, and it's a little bit different, but almost the same. They look like this in the body. This is actually from a shot where this is an injury. That ball should be in there. And the strap comes down through this tendon. See it? They come down through the little hole there. And this one is underneath, locked in to what appears to be muscle, or it could be bone. Because they do both. They lock into bone, they lock into muscle, but they all have the same purpose, is to be pulled against this tendon, which is tough and hard and strappy. These are floppy. They can twist like this. As the tendon moves up, the ball goes down. Simple as that. And they're locked in here. They're part of this tendon mat. So the ball strap comes down, locks in the ball through the hole. The ball anchors here. Everything can move this way, pulled against the anchor. This one pulled out. That's the injury there. Now, these are seen quite large right here on Earth in Arches National Park. I'm telling you, you got to get your mind open and be able to see this stuff. You just have to open your mind up. There it is right there. There's a guy standing on that tendon strap. The tendon mat underneath, the other one, the one I showed you, pulled out. So this whole ball pulled out. This one here, this stuff is eroding away from the ball. The ball's still here. These are tough. These don't normally erode. You see there's another one here. The straps, not so tough. They have to be flexible. They're just not tough. There's one here that has broken right off. Usually they come to a transition, and then they come out from there. Well, the other ones I showed you, they come right off the strap. You see over here, there's a whole bunch of more biology going on over here. This whole area is loaded with these balls. See, there's one here. They're all over here. And then they make arches, and there's a lot of them. It's not just this one. This one here is the best I could find. And it absolutely proves what I'm saying. There's another one here. It's still in the ground. That I don't think came to here. I think that one came over to here, but it's hard to say. Looks like it's too close if that one's that far away, but who knows. This is reality, my friends. It's just a shocker, but it's reality. Okay, I think I mentioned this, and I don't think I showed it to you. This right here is the valve, I believe. And what would happen is the blood would come in, and then it would come back out here. And that little pincher would open up, and the blood would come through. And if the blood tried to go back, it would come back and clamp together. That's the way vein valves work. They open up as the blood comes through this way. It has to open up. All right. If the blood tries to come back, it pinches together, and it doesn't allow it. Vein blood is supposed to only go one direction. The red blood can go up, down, anywhere you want. You see that green? I would be willing to bet this is something possibly alive. This is in the interstitium layer between the outside layer which is the outside, it's almost fleshy. And then you have a membrane underneath, and then you have a fluid-filled highway, which is the protective layer that protects this entire ball. That was its protection layer. And every single organ in your body and your muscles, everything, they have a membrane around them to keep them separated from all the other nasty chemistry in your body. And those membranes have fluids in them, and they have fluids that actually have living creatures in them. In our body too, they're bacteria. I think this might be bacteria. I think it might be bacteria. These colors are indicative of chemistry. Chemistry is indicative of the material that is making that light. The molecules make the light. The molecules are a certain structure, and they bounce back a certain frequency. That's why it's red everywhere. And then we're red down in here. It's basically the same sort of material as this. And then you got your membrane, and this is ripped. This is not an impact by any means. No way in the world is that an impact. This is a tendon anthesis ripped off of our moon's surface. And you can see it pretty easily here. You see this is ripped off. That's not an impact coming up. And this, it looks like it got ripped in this direction. Isn't that something? That's our moon. And this is not a silly looking picture either. This is pretty close. It's a picture with using spectroscopy, which is the light frequencies which the materials themselves give off. So these different colors are different types of matter. I hope you understand that. It's very simple, basically, and I think I've made it pretty obvious. And what's out here, nobody knows. I've never seen anything like this before, other than what Dylan sent to me. And it's something's going on there. And I saw something about how Musk was all upset or was worried about something up there. They found something on the moon they didn't expect when they had the blue ghost landing. And they say, oh, no, that's been debunked. That's all crazy. Well, maybe. I have a hard time believing a lot of the things I hear from anybody. It just doesn't matter. If it's something that they don't want to say or have heard, it's just not heard. It's a strange society, where you can put something out and it'll go out viral in 10 minutes if it's a kitten or something, or a guy shooting a basketball from who knows how far away. And but something like this, where it changes everything in our life, in our history, in academia, in schools, it's crushed. And it's not the first time. This happened to Velikovsky too. That's why I wrote the book about him 10 years ago. That I called it Minds in Collision, because they couldn't accept. He had the truth and they couldn't accept it. So it's just the same as it is now. Now this, I think, could be actually some kind of a ball and socket area type of thing that goes between bones. You see this bone right here? You see that little hole where all those little tiny holes are in there? I think that could be like in here, and then that one would go into another bone where you could really do some moving back and forth here. Sometimes they just have this in like this spot here, and then coming out it would splay into a bone and just be like a ligament holding onto this bone through the ball part. But these are creatures, I don't have any idea what kind of a creature it is. It's just, they're very similar to human beings. I mean, the blood is red blood. I know it is. And I know the materials that are going to be in there, they already found them. And this is crazy to do this at Bennu. Look at this. That's muscle tissue. That's like little fibers of muscle. That didn't get there for no reason. And it's from these sarcomeres right here. They're bundles, and then they're sarcomeres. And that's what we've been paying for, is to walk around in circles all the time. And now they're going to the moon. They better know where they're going. They should know. And I got some pretty good information on this. I'm one of the only ones that has done this or understands this. And I understand it pretty well. I've been working on this for a very, very long time. And it's a crazy world, my friends, but it is true. It is true. And there were giants on the earth in those days. They're here now still somewhere. Or what I was just showing you is all over the earth. And that's in my backyard. That's a 3-foot long fingertip with the fingerprints still on it, DNA tested, human Homo sapien, mitochondrial DNA. Hard to deny any of this. And then, of course, there's the light research. And this overthrows all that we've been taught about. Light can't slow down, light can't speed up. Of course it can speed up. It's speeding up right there. And we can split it. It's a black and white particle. The black is separated now from the white. That's fission, that's fusion. None of this stuff is allowed to be spoken of because it overthrows everything that the big shots have been telling us we have to believe. And now it's become really just silliness to dismiss all this, because I think we could use that white right there. If you can get an electron shower like this, it comes down here, not too much energy, it gets a little more energy, and right at the venturi, right through the roof. And they have proven that as well, because here's the proof in the pudding. This is from CERN, not me. The particles come in sort of low energy, you know, energetic, but not really high energy. And when they hit the venturi, right through the roof. And why? Because of the electron showers. See, the E means electron. Showers. They come in, they start getting a little more energy, as I showed you, a little wider, and then they hit the venturi, and you get 400 times, or at least a couple hundred times as much energy as you started with. That's what they say. That's not me, that's them. And I would think Elon Musk would be interested in that. Get a little extra energy. And here's what it says. Right now they're doing proton-proton collisions. We don't do that. We use light. So they had to break it down until they got down to where we started, was electrons and muons. And then they ended up getting from mega electron volts, millions, up to 100 billion electron volts, to trillions of electron volts. The energy increase is staggering. And I've shown just the same particles they found at Fermilab. That's from Don Lincoln's article from Fermilab 2013, I think it was. We found these, I think it was 2014. And I contacted them, and they had no interest whatsoever, and told me to go away and don't ever come back. And worse. And here's the showers. High energy. There's the muons. They back off. They don't come. Here the shower cone continues to expand until the last layer. It gets bigger and bigger and bigger. That's more and more energy. So it's crazy to let the people that don't want us to understand things, because they just don't want to lose their status. They should say, let's start to investigate this. They can keep all their status, and I don't care what they do. But if we're not getting anything for their status, other than to say, have them publish papers of, you know, and making a word salad out of everything. It's absolutely amazing how they can distort literally everything. I make everything simple, easy. Once you understand it, you're done. You can go back and say, whoa, Roger, wait, that can't be right. I said, well, what's the matter? And they said, well, that's not right because I don't know what they're going to say. But say whatever you want to say, and then we'll talk about it. But I'm not going to just be shut up and be told to be quiet because I'm not saying what they want to hear. I never have said what anybody wants to hear. I got to be honest with you. I've had this situation for a very long time. This is ripped away. That is not a crater. So anyway, that's it for today, I guess. I don't know if I should go any further with this. I've been on forever. But I was showing all the dinosaurs and all that stuff. A giant sea monster. This isn't even real. These aren't real teeth. It didn't have any teeth. They put those teeth on there to make it look like something special. When they found it, the teeth don't last. For some reason, I don't have anything I found with teeth. Nothing. Teeth didn't last and bones didn't last if they were outside of the fascia. Gone. Inside the fascia, yes, they lasted. But if that was ripped off of there, it would just dissolve. And the same thing, trees dissolve. The cellulose did not make it in the boiling hot flood with the silicates and the salts. They just didn't hold up well. They just dissolved. They have a different type of cellular structure than meats, which is a soft tissue, and that is preserved fabulously, and especially because of the collagens, which is the fascia. All right, so I love you all. Thank you. See what you think. Pass this around. Get somebody to pay attention, and then we can discuss it and discuss our true history and when the Triassic happened, the Great Flood, and what the kind of creatures were here before the Great Flood, what their feet looked like, spring feet, no toes, Oompa Loompa. I got them all. And I mean, I'm serious. I got a ton of different styles. And they all came from the Triassic era. And I am right square in the Triassic, exposed Triassic, right there. I mean, in dead center in that black spot. So I am in the highest up of the Triassic, because that's where it bubbled up. I'm up sort of on a pretty good hillside. And they're just everywhere. And somebody said from Pennsylvania, they got them just laying everywhere too. Well, that's another exposed area. He just walks out and he just picks them up. I do too. I can pick them up all day long. I didn't have to dig for hardly any of this stuff. So, and everybody now, the kids, they want to go out and I'm hearing really heartwarming stories from families that their kids are really interested in. Young kids, they go crazy for this. But and it's true and it's reality. It's not something that to lie to them because you don't want to scare them. I don't know if that's a good idea. If you grew up understanding this, because I think the PhDs and all, they're just scared. They're just totally scared. And especially scared for their status and position, saying that, oh, this is nothing, that's just a chunk of dirt out in space, meteorite that just showed up for no reason. No, that's a hip bone. And it exudes exactly what the astronauts say. You see this? What does space smell like? Astronauts describe the smell of space as seared steak or burnt meat. The aroma, along with other metallic and acrid notes. Your blood is virtually all metals. It's all of these transition metals, basically, are in your blood. And even more up in here, too. They're just saturated with metals. And polycyclic aromatic hydrocarbons. All right, so the atomic oxygen, and they're talking about how the possible explanations. Well, polycyclic aromatic hydrocarbons are they're meat. They're found in charred foods on Earth. They're the meat. It's also present in steak as meat. They say, well, it may be clinging to the spacesuits and equipment contributing to the smell. Yeah, because it's meat. Because when they come in off of the walk, they take their suit off and they say, smells like a sirloin. And they're talking, well, it must be cellular explosions. I'm sorry. They should be saying it's magma. Everything is magma. So here you go. 500 feet across, squirting out barbecue juice everywhere in the universe. It's everywhere. And every one of them was biology. Every single one I showed you. Right, this is biology. This is some kind of biology. Like I say, I'm not sure about what it is, but it's biology. That I can tell you for a fact. This was a finger, Omao. I had some other ones here too. Well, the moons, that's biology. That's the hearts are biology, Psyche and Bennu. I mean, it's just biology everywhere. Our moon's biology too. So anyway, I'm going to leave it at that, and let's just see if we can get some reality in our life. And you know, don't be afraid to talk. It's true. If something's true, it's true. All right, I love you all. Bye. Okay, my friends, we're going to be talking about the moon. We're going to be talking about what is in space, and this is our moon, the side that we can't really see, and these different colors are different layers of the moon's surface, and I do know what they are, and I can tell you what the chemistry is, and I can tell you why you have this abrupt transition around here, and the smooth layer underneath this grippy layer. And then these two holes here. I'm going to explain all of this in a minute. We're going to be talking about tendon enthesis and how the similarity to moons are. Okay, here's another shocker du jour. This is the same as that. This is a lung. You see that little hole down in there? You see that? That's the same hole as this. This is basically the same as this lung that came through space. You say, oh, come on, that's crazy. No, it's not. This is exactly what a lung is. It's made of iron, basically, you know, metal. And this one is a terrestrial one, didn't come through space. But you can see all the red in here, all the iron that's in here. In the fabric, it just bled out, basically. And it looks like that, only that one turned into metal. Now, I said that little hole right there. Look at this little hole right here. You see that? That's the artery. That's where blood fed into that lung. And they have pictures with kids sitting in here. It's that big. It's huge. They got kids that were sitting inside of these little cavities in here. They took this from the Native American people. It was one of their sacred objects.